Hi guys, welcome back. So today we're going to be doing orthographic projection, right? So orthographic projection is just easy, guys. It's just a way to imagine how things would look like, how would you interpret their drawings, right? So orthographic projection, there are certain principles that should be followed, right? In orthographic projection. Okay, so for this assignment, we're going to be doing third angle. So I'm going to give you the rule or the principle that you must follow when you're using third angle projection, right? So for third angle, what you want to know is the way you visualize an object, or the way you visualize whatever you're supposed to, whether be it a house, be it what. If you the way you visualize it, that's how you project it to the plane of projection. What do I mean by this? If you view from the top, right? Let's say you're looking at a house, right? If you look at the top of the house, on paper, the roof, you just put it on top, right? I don't know if you get what I'm saying, right? And the front elevation always comes below the plan or the top view, right? Then if you view a side elevation from the left, you project it to the left side. Unlike what we were doing in today's assignment, you can see that we were viewing our drawing or our 3D object. The end elevation or the side elevation was to the right. That's why we put the side elevation to our left side, right? I don't know if you get it, right? So that's just the principle of drawing third angle. The way you view is the way you project, right? So let me just try to draw a small diagram. It should be just a 3D or something, right? Okay, so what I want to show you here, guys, is I want to show you how you project these things, how you project the top, the end elevation, the front elevation, right, onto your plane of projection. What we call the plane of projection is that's like the paper. A paper can be a plane of projection, right? It's like where you are supposed to be drawing, right? That's a plane of projection, right? So most plane of projections are vertical. We say they are vertical even if you're drawing on a horizontal surface, but we say they are vertical, right? Most of them, right? So we have our top, front, and end elevation, right? Okay. I don't know if I think it's clear. Today I tried to get a whiteboard and a marker, so I think it's clear. So now let me just try to write for you guys like what I was just trying to explain. So as you can see, I'm writing here that I'm just trying to write so that you guys can maybe take notes, but I don't know if you want to take notes, so that you just remember like the principle that I was just highlighting, that the way you visualize it. So now most people would want to know like why is this we have first angle and third angle. It's just a funny theory. There is what we call the standard. I don't know if you have read those two diagrams we were given that show the angle of projection. Those ones. If you had noticed, you see that there is the one that was written American and the other one was written standard. So the other one is just used by Americans. It's just like how we have the British English, American English, like those type of things, right? So now let's go to the next stage. So now I want to show you, let's say you want to draw on a plane of projection. So now the top view, as I said, you put it on top, like on top. Then the front elevation, right, or the front view always comes below, right? So from the drawing that I just did before, our end elevation was to our right. That's why I put that here, the end elevation on the right side, right? Okay, so now let's go to the next step. So now the next step is we want to draw the the diagram that we're given, right? We want to draw the orthographic views of this diagram, right? So as you can see, we have the top part, right? And we have that, right? So I'm just highlighting the size that we see, okay? So now let's go ahead and draw our center lines. So today I'm using a more darker pencil than the one I was using yesterday. I don't know if you can see it, guys. Okay. So now you just measure around 1 centimeter, which is 10 millimeters, away from the center line that we have constructed, so that you can start drawing the diagram that you were given. So now I've projected a line just as a starting point where I want to start drawing. Okay. So now I've just realized that that scale might be a little bit bigger. So I've decided to use a scale of 1:2. Okay. It's just for the sake of this tutorial. I don't know if we are given any scale to use, but for this tutorial I'm going to be using a scale of 1:2. So if you measure the total, it would give you a 240, and you divide that 240 by 2, then you get 120. So now I've marked my 120 point. Now I'm drawing a line at that point. So that's the 120 using a scale, right? So every dimension that you get from this diagram, you divide it by 2, like I'm doing here, to get 60, right? So 60 will be the length of the...
You want to get a point
of the diagram that we are going to be drawing.
You just want to start drawing.
Right.
So you can just go at any point on
the
your
length.
center line that you would have
constructed. It might appear as right because we are drawing on a vertical point. Right.
So now
this is the bigger box that we'll be seeing if we view from the top elevation.
Put a distance like...
So now we want to draw those two brackets.
15 millimeters.
As you can see, there's a center line, right?
From the center line.
There's a center line that
so
we must take note of. So we want to divide that line.
I'm using a scale of 1
so that we get the...
So if we
get that center line. So that was 60. So now our center line is going to be
plus 30 on the right side and 30
millimeter
on the other
mark. Okay.
We get what,
so now I'm drawing
right?
the
so 240 is our
center line
that
at the 30 millimeter mark.
But I'm going to be using a scale of 1
now let's draw it.
2. So that means I will need
so this is the center line
like
that we are going to use to draw the two brackets
on my paper.
So the
you can just
brackets,
take any point from
they're
this,
marked 25 millimeters.
Then
so if you divide 25 millimeters by 2, that's our scale 1:2. You get 12.5. Then you have to divide 12.5 by 2, because on each side of the center line there's a bracket, right? So if you divide 12.5 by 2, you get what? 6.25. Then you can draw that 6.25. So that's our bracket, right? That's how we draw the bracket. Okay. So now I want to draw the top part, right? The top part. So there's also a center line of that top part. That's what I was highlighting there. Okay, so now we divide that line, which was 120, we divide it by 2. So that's the mark we have. The center line is on the 60 millimeter mark, right? So let's project our center line. So now we have the center line that we're going to use to draw that top part, right? So let's go ahead and draw it. From there to there, it's written... from there to there is written 120, right? Exactly. So the half would be 60. The half is 60, right? So what you want to do is the 60, we divide it by 2. That's our scale. So it means on each side, we'll be having 30 on our paper, right? On our drawing paper. So you measure 30 on each side, right? 30 on each side of your drawing, right? Okay, so we've measured our 30. So now we are drawing our projection line, okay? So let's draw our projection line. Okay, so now since we are done with the length, we now want to draw the width, right?
So I was just trying to show you guys that this drawing is not starting on the where we have the bigger surface. So it's starting from more like inside the bigger surface that we had, right? So now we want to go ahead and draw the width of our top part, that's 80 millimeters. So we divide the 80 by 2, our scale, we get 40, right? Then we divide the 40 by 2 to get 20, so that on each side of the center line that we had drawn before, we measure 20, right, to get the total of 40 millimeters, right? So it's just a matter of using scale, guys. Don't be confused. So now I'm measuring the 20 on each side. So that line that I'm going to be drawing there, it will be a 40 millimeter line. All right. Okay. Exactly. So that width is 40 millimeters. So now I'm darkening those brackets that we had drawn as faint lines before, because now we know where they are ending and where they are starting, right? So now let's join those two, right? Okay. So this is simple, guys. Like you don't have to do much. Okay, so let's go ahead and darken what we have already obtained before. Okay, so now we have our bracket. So now we want to have that smaller part, right? The smaller part that we have on top. So that one is it's written slot 80 by 40, right? 80 by 40, which means our length is 80 and our width is 40 millimeters. So now what you want to do is you go to the center. We want to draw the length, which is 80, which is 40. So we divide the 40 by 80. If you divide it by 2, you get 40. So the 40 divided by 2, you get 20. So which means you're drawing 20 on each side of the center line, right? So let's go ahead and do that. I put my 20 on that side. So now I want to go ahead and draw the width, which is 40, which is written 40 on the paper. So you divide the 40 by 2, get 20. So now for us to draw, you divide that 20 by 2 to get 10 on each side. So which is what I've done, right? So you go ahead and draw that. So now you go ahead and darken, because we are done with that measurement. So the other thing in drawing is you always want to start with faint line, so that if you make a mistake, it's easy to rub, right? Than starting with darker lines. Okay, so now what you want to do is you want to draw those 4 holes, written 4 holes, 30 by 15, right? Okay, so 30 by 15, it will just mean that the length is 30, the 15 millimeters, there is 30 by 15 millimeters, sorry. So this means that this is 30 by 15 on the actual ground, but on paper we divide all those by 2, right? So the center line seems like it was aligning with the edge that we obtained from the top view. So I'm just going to use that edge as my center line, right? So let's go ahead and draw that center line, which is aligning with that edge of the top view that we have obtained before, right? Okay, we are now drawing the center lines on top. So now we also want to get the center line that's written 30 millimeters. So you divide the center line by that dimension by 2, you get 15 millimeters. So now I'm measuring my 15 millimeters. That's where the 15 millimeter mark is. So now I project the center line going upwards, right?
Then I go to the other side, I also measure 15 millimeters, right? So guys, take note, I'm using a scale of 1:2. Don't be confused by that. It's just a normal scale that I'm using, right? So now I project upwards. That's my center line that we are going to use to make those, to draw those 4 holes that we are given, right? So it's 30 by 15, so which means the length is 30, right? So you divide the 30 by 2, you get 15, right? But you go there, you want to measure 7.5 on the right side, like what I did, and 7.5 on the other side to give you 15, right? Then you project that on, right? Sorry, you want to draw the width, which is 15. You divide the 15 by 2. If you divide 15 by 2, divide 7.5 by 2, get 3.25, right? So you want to put 3.5 on both sides. So I was trying to be accurate here because 3.25 it's a little bit smaller. So I was trying to be accurate, but yeah, I managed to do it. So you now project those ones, right? So now what you want to do is you want to draw the hole itself, right? So I have just projected that line going upwards so that I would use it later. But now what I want to do is I want to darken that hole that I've just constructed there, right? So let's go ahead and darken it. Okay, so now we have our hole, right? So we also want to have the hole from that side. So since we have already projected the length, we now want the width. That's 15 millimeters. We divide the 15 millimeters by 2, get 7.5. Then we divide that 7.5 by 2 to get 3.25 on both sides, right? So now, which is what I've done. Now we want to darken the smaller box that we've just constructed, right? Let's darken it. You see, that's the drawing we want. So now you project that one going to the right side, because we also want to draw the same holes that side. So now, since on this side we don't have the length, we want to establish the length. The length that's 30 millimeters on the actual ground. We divide it by 2 to get the dimension we're going to put on paper, which is 15. Therefore, that 15 is divided by 2, so that you know that on the right side of the center line, you are putting 7.5, right? So it's 7.5 on each side, right? Which is what I did on each side of the center line. Now I'm darkening exactly. You see, now we have our full top elevation, our full top view, our full plan. That's the plan, guys. That's just it. So now we want to project all the edges going downwards so that we obtain our front elevation, right? So you have to take note, each and every edge that you see on the top elevation, you project it going downwards, right? Because it will help us to get the front elevation. So now let's project those ones going downwards, right? Right there, I was measuring 10 millimeters, sorry, so that I know where to start drawing my front view. So as you can see, that top part is aligning with that, right? So now we want to get its height, which was 40. So you go ahead and draw 20, because we are using a scale of 1:2, right? So go ahead and draw 20. Okay. So now you join the two. So you guys, you now see that it's now easy. You'll be just following those projection lines that you've projected going downwards, and just making horizontal lines using your T-sway. So now we have that face of the top part, but there's that hole that we're given, right? So that one we hadn't projected it downwards. So now let's project it going downwards. So for something that you are not seeing, if it's a hole, you draw it using imaginary lines, right? Imaginary lines, they're just dashes, right? So I've realized that this hole has a depth. That one, that's the depth that's written there. It's written deep 50, so which means it's 50 millimeters deep. So using our scale, it will be 25 millimeters deep. So you measure 25 millimeters. Then where the 25 millimeters is ending, now you go ahead and you mark where the 25 millimeters is ending, and you also draw a dash. You draw dashes, right? To show that it's hidden detail. We call it hidden detail because you can't see it, but it's there. It's a wall that's inside a certain shape, right? That wall, right, is going deep. So you show it as dashes to show that there is something which you cannot see, but it's there, right? So you show it by using dashes. So now we want to draw that bracket, right? You see it as an incline on the front view. But before we draw the brackets, we want to draw that height of the base, the height of our base, right? So let's draw the height of our base. That's what? That's 40 millimeters. So you divide the 40 millimeters by 2 to get 20 millimeters. So that's what we did there. That's 20 millimeters. So that's our base. That's the base that we've just drawn right there, right? So from the base, we now want to draw the bracket, because now we have our complete base. So our bracket is just going from the base to that to that shape. So you draw your bracket and attach it there, right? Okay, so now you have your drawing. So now what you want to do is you want to draw those 4 holes. So those 4 holes, we also use the same method that we used, because it's a hole. It's something that's there but we can't see it, right? So we also use dashes to show that there's something that we can see. So they are called imaginary lines, right? So we use the imaginary lines, which are dashes, to show that there is a hole but we can't see it, right? So now we are done. That's our top view, guys. Just that, right? So now what we want to do is we want to go ahead and draw our left side, right? It's written left side there, but you can also call it left elevation. So as I have said before, if it's written left side, if it's in third angle, you just draw it from the third angle, from the left side, sorry, right? So now what I'm doing is I'm projecting those lines to the left side, because that's where I want to draw the left side, the left view, the left elevation, right? So this is what I'm doing right now. I've projected not all, but some of the lines to the left side. So now you go ahead with your 45 degree. You can choose a point, any point, to draw a 45 degree line. Why do we draw a 45 degree line? It's because if you project a line, a vertical line, where that 45 degree inclined line is meeting the horizontal line, you get 90 degrees. So that line, it's straight, it's going straight downwards. That's why we use a 45 degrees, 45 degree set way. So now I was just rubbing so that we just have neat diagrams, right? Okay, so now I'm projecting going downwards, right? So let's project going downwards.
Okay, so the reason why we are projecting going downwards is that those lines that we projected going downwards will give us the true shape of the of the left elevation, right? So now, as you can see, we now have the true length of the left side. Without even measuring it, you also have the true length of the thing that you want to draw. So there won't be any need of going to the diagram. You now have to just draw, right? As you can see, now we are drawing we want to complete the base. So now we are drawing the base. So we've just completed the base. That's the base we have done there, right? Now we want to draw the bracket. That's our bracket. So if you go there, you see the lines that give us the bracket. Those are the lines that I'm highlighting, right? So you go ahead and draw your bracket. Okay, so that's our bracket. That's how we see it from the left elevation, right? So we have drawn our bracket. Now we want to go ahead and draw that top part, right, which is right there. So I realized that I didn't project that to the 45-degree inclined line. So now let's project them. We have projected them there. So now let's project them going downwards so that we get where it is. Okay, now we are done. Let's project right there. Okay, so that's where we have our top, that top part, right? So now you darken that line, and you also have to darken the vertical line, right? So I was just confirming if that's the line. So we just go down and also go down there, right? So now we have that top part, right? That's how we visualize it. So as you can see, we see the bracket, the face of the bracket, that's the face of the bracket, and those two faces. That's how we see them if we look from the left elevation, from the left side, right? So now we want to draw that hole. Still on that, on our left elevation, we also can see it. So you also draw it as imaginary lines. So let's go ahead and project those lines going vertically downwards, right? As you can see, I'm now drawing it as construction lines. So not as construction lines, but as imaginary lines, right? As you project it downwards, you draw them as imaginary lines, so that to highlight to someone that there's a hole, right, going downwards, right? There's something that's there, but we can't see it. That's the purpose of drawing using imaginary lines. Then you also want to draw those holes, right? Those holes are also imaginary. So you just project, right? So as you can see, I'm now drawing them as imaginary lines. So we had already projected those lines going downwards, right? So now all you want to do is to draw them as imaginary lines. Okay, so now you have your three elevations. You have the plan, the front elevation, and the left side elevation. So that's it for tomorrow's assignment, guys. That's all you wanted to do, right? So you can go ahead and write front view, front elevation. So thank you, guys. I know Chirungu Vara, but yeah. So I've tried. If you can follow the steps, you can get what was required for the assignment that we were given. Okay, so if you can follow through, if you have anything to ask, you can just
come and I will help you. Yeah. Okay, so thank you guys. Thank you so much for watching the video. If you have made it to the end, thank you so much. Don't forget to like and share with other colleagues. Okay, so thank you so much, guys. Hopefully this was helpful and it will help you in the near future. Thank you so much.